We're starting section 1.4b, which is on parametric equations. And what we're going to do now in this particular lesson is we're actually going to write the parametric equations given some information. In this first problem here, we just want to draw a line segment from -1, -3 to the point 4, 1. When we do this, essentially we want to be able to see that particle moving along this line segment. Please understand that this has an initial point and a terminal point. -1, -3 is the initial point, 4, 1 is the terminal point. And here's how we're going to do these types of problems. We're going to say the x-coordinate is going to start at -1, and it's going to move some distance a in a certain amount of time t. Okay? Likewise, for the y-coordinate, we're going to say it starts at -3, and it moves a certain amount b, we're going to call it something different, over a certain time t. Okay? And we're going to set them up like this every time that we have one of these segment ray type problems. They give us 2 points. And here's the idea. The x-coordinate is starting at -1, and then it's going to 4. Now we can make the time element be anything that we want it to be. We can make it be 1 time element, 2, 10, 100. That just determines how fast it moves along the line. So when we're going to set this up, the easiest number to assign to t is 1. But we could make it anything. If you make it 2, 3, 4, now you're going to get a fractional value for a. So it's going to make it a bit more complex. It's a lot better if we simply say the x-coordinate is going to go from -1 to +4 in 1 time element. So we're going from -1 to +4, and we're going to say t is 1. Understand, we could pick any value we want for t as long as we set our parameter interval up accordingly when we go to set the parameter interval. But it's much easier if you just make the parameter interval go from 0 to 1. That's how I'm going to set all of these up. If you add 1 to the other side, you're going to get a equals 5. So we have the x-coordinate can be defined in terms of t as being -1 plus 5t. That's going to be our x-coordinate definition. I'll do the y-coordinate in a different color so that you can see. The y-coordinate, very similarly, is going to go from -3 to +1. And we might as well say in 1 time element. Whatever we use in the x, we want to use the same time element for the y. It's going from -3 to 1 in 1 time element. We can make this be anything we want, but we're going to use 1. Add the 3 to the other side, and we get b equals 4. So we can write the y-coordinate is -3 plus 4t. We have now defined both our x-coordinate and our y-coordinate. But when we set up a parameter or a parametrization for a curve, not only do we have to define the x and the y-coordinate, but we also have to define the parameter interval. So the total solution for this must say x is -1 plus 5t, y equals -3 plus 4t, and then we must say this is only from t is greater than or equal to 0, but less than or equal to 1. That's how we're going to set it up. Again, at time 0, we're going to start at this point right here. And 1 time element, I keep saying time element, it could be a second, it could be a millisecond, it could be a thousandth of a second, it could be, it could be an hour. It's some time element that it's going to go from the first point to the other point. And then it's going to stop. It has a definite start and a definite end. Let's look at this now on the graphing calculator to see if it actually does give us a line segment from -3 to -1. We're going to have to type in -1 plus 5t in for the x-coordinate, -3 plus 4t in for the y-coordinate, and we're also going to have to take care of the time interval and make sure that it only goes from 0 to 1. So let's call it up. Here's the smart view. We need to make sure that our mode is in parametric mode. We were still in it from yesterday. So I'm going to go y equals. I'm going to define the x coordinate. I'm going to clear this out, and I'm going to say it's -1 plus 5t. Enter. I'm going to make the y coordinate -3 plus 4t. Enter. There's my x coordinate and my y coordinate. But before I graph it, I need to set the window. And the window is going to go from 0, because that's my smallest, that's the left side of my parameter interval. Clear this out. I'm going to put a 1, because I'm only going to go from 0 to 1. And most of the problems that you're going to set up, these last 3 problems are going to go from 0 to 1. Okay, let's graph it and see what happens. If I hit graph, okay, I get this nice segment. It looks like it's starting at -3, -1, -3. It might be hard to tell, so let's change the window just a little bit. Let's make sure that the y coordinate definitely goes down past -3. Maybe we'll make it go from -5 to -3.1. Does it definitely start and stop? There it is. It goes from this point right here, -1, -3, and it goes up to this point here. You maybe don't see it real clearly, but that's the ending point of 4, 1. So if we go back, okay, it's a line segment that starts at -3, -1, and goes to 4, 1. A couple things. If I decided to make this time interval 10, I would have to divide, and I would get an a value of 1/2. That's fine. I would just plug 1/2 back in here, and it would change this 5 to a 1/2. I would have to use the same time element over here. I would have to use the same over here and put a 10 here, which means that when I divide it, I'd have 4 divided by 10, or 2/5 would go right here instead of the 4. And that would be perfectly fine. I could define the x and the y coordinate in that manner. But then I would have to set my time interval to go from 0 to 10 instead of from 0 to 1. So you can use any time element you want, but it's easier if you set your parameter interval to go from 0 to 1. Okay, there's the first one. Let's take a look at the second. Define the lower half of the parabola x squared plus 2x. This one is pretty darn easy, because essentially what's going to happen on this particular problem, whenever you see a polynomial, they already got y equals, all we need to do is set x equal to t, and then set the y coordinate equal to t squared plus 2t. The key to this is just to set the parameter interval correctly. If we only want to graph the right-hand side of this parabola, we're going to have to decide where does that start? Well, if I graph this parabola just normally, where would the vertex be of this parabola? Okay? If I want to find the vertex, one way to do it, find the x-coordinate of a vertex, is to go -b over 2a. So the x-coordinate of this parabola, the vertex of this parabola, is -1. I could plug it back in. -1 squared is 1. I get a -2. It's the vertex of this parabola is the point -1, -1. So the bottom line is we can only graph this particular situation if we want the lower half. First of all, that doesn't make sense, the lower half. It's either the right half or the left half. Let's say we want the left half. Okay, so cross that out. This should say left half of the parabola. If we only want the left half, we want to graph it then when t is less than or equal to -1. This is how I'm going to have to set up my parametric equation. That's the answer that the book is looking for right there. Okay? Now, when you're done, you should always come and check to see if it works. So we'll plug it into the calculator and see if we really do get the left half of that parabola. I like the fact that we're looking at one of these when t is less than or equal to -1 because we really haven't seen one of these yet. It's going to have a terminal point, but not an initial point. This is the highest value. So on a problem like this, the initial point is none, and the terminal point is the point -1, -1, that vertex. Let's see if we get the left hand, if we graph this, what's in blue right here in our calculator. Going back to the calculator, going to y equals. I'm going to clear this out, clear out the two coordinates. The x coordinate we're going to define just as t. The y coordinate is going to be defined as t squared plus 2t. Enter. But we have to set the correct parameter interval. If we don't do the correct parameter interval, it could be any part of this parabola. Again, the t values go on forever in the negative direction. So I might start with -10, but I may have to go backwards even further if it doesn't go off the screen. But I need to stop at -1. That's where I need to stop. That's where the time element stops because t is less than or equal to -1. T-step here is fine. You can leave the min and the max the same. You can change it if you want. If you want to go from -10 to 10 or whatever you want to go to. But if we graph this, here comes a parabola, and it stops right where it's supposed to. It stops right here at this vertex. Okay? So that's how we can easily graph the left or right-hand side of a parabola. Okay, so let's go back and do this last example then. There's only 3 problems in your homework as well. So here's the third example then. We want to graph a ray now that has an initial point of 2, 3, and that passes through the point -1, -1. It's just like the first example that we did. We're going to say the x-coordinate is going to start at 2, and it's going to travel a certain distance a in a certain amount of time t. And the y-coordinate is going to start at 3, and it's going to travel a certain distance b in a certain amount t. Again, we can let this time interval be anything that we want it to be. However, it's much easier if we say it's going to take one time unit to get from this point to this point. If you want to make it a different time element, go ahead. It just makes it a fraction instead. It's a lot easier if you just make it one time interval. So, the x-coordinate goes from 2 to -1 in one time interval when t is 1. Subtract. You get a equals 3. So our x-coordinate is going to be 2 plus -3 times t. Likewise, our y-coordinate is going to go from 3 to -1 in one time interval. Subtract, and we get b equals -4. So we get y equals 3 minus 4t. The last thing that we have to do then is just set up the parameter interval. Where do we want it to start? Where do we want it to end? The only difference here is we're still starting at 0. So the time is going to be greater than or equal to 0, but it's going to go on forever. There is no end point. So it's best to write it really like this. This is going to be when t is greater than or equal to 0. So the only difference, you set it up exactly the same way as a line segment, except a line segment will also have an ending point for our parameter interval, where here we don't have an ending point. It starts at time of 0. At one time element later, it's going to travel through the point -1, -1, but then it's going to keep on going because it's a ray now, not a line. That's the only difference, is the time element. The parameter interval is what it's called, the parameter interval. So here we go. Let's type these two in. gotta write them down here quickly. The x coordinate, again, is going to be 2 minus 3t. The y coordinate is going to be 3 minus 4t. And the time parameter interval is going to be t is greater than or equal to 0. So here we go. I'm going to clear this out. Go to y equals, clear, clear. This is 2 minus 3t. This is 3 minus 4t. Okay? And it's going to be when t is greater than or equal to 0. So when we set this window, our t min is going to be 0. Our t max is going to be 10. Step 0.13. And we are going to go zoom. Now, we don't have to go zoom. Just hit graph. Okay? Now, notice I made the t max 10. That maybe isn't enough. I may have to go further than that. But let's see. We graph this. It is supposed to start at the point. It's supposed to start at the point 2, 3 and go through the point -1, -1. Well, it doesn't look good. Let's go back and take a look. Again, this should be back to our window. T. So when we look at this, our viewing window, it's kind of hard to tell that it really starts at 2, 3. So let's set our window, change it a little bit. Let's make our x max maybe be 8. And our y max, maybe we'll set that at 8. So we see it a little bit better, and we graph. And we can see it starts at the point right here, 2, 3. It goes through the point -1, 1, and it keeps right on it going. Okay? So that's what we have to do when we set these up. The key is to set the correct parameter interval based on where you want the curve to start and stop. I think that will help immensely when you do it. Going back, here is the assignment. It's 3 problems. I really think if you follow along with these 3 examples, you can get 28, 30, and 32 on your own, and hopefully we won't have to spend time in class going over them. There's 1 or 2 problems maybe like this on the test, but the bottom line is I really feel we can get these if you take a look. See you in class.